Consuelo, everybody. Okay, what we're going to talk about this time is fractional exponents. And really, the main idea I want to get across is that a radical and a fractional exponent are just the same thing written two different ways. So here, what's the fifth root of 32? It means it's 2. Okay, what's 32 to the 1/5 power? It means the same thing as the fifth root of 32, but the thing I want to emphasize is I would not do what Alex does. Alex changes everything into radicals. I would not do that, okay? I would just deal with it as an exponent. So what are we going to do? We're going to factor 32 and call it 2 to the 5th power and raise it to the 1/5 power, and then just use the exponent rules. So 5 times 1/5 is 2 to the 1st, okay? So let's just take a look. Remember, the exponent rules don't change no matter how bizarre the problem looks. So we have x squared times x to the 3rd would be x to the 5th, right? Because we had the 2 and the 3. Well, what do you do here? You just add the 3/7 and the 2/5, the same thing you would do. So we have 3/7 plus 2/5, and then you need to get a common denominator. So the common denominator is 35. And then you on the first fraction, you multiply top and bottom by 5. And the second fraction, you multiply top and bottom by 7. So you get x to the 29/35 power. Okay, when you divide, what do? You subtract the exponents. So you would take 7 minus 4 as x to the 3rd. So what are you going to do here? Same thing, you subtract the exponents. It's 9/17 minus 1/2. Okay, get a common denominator. So the common denominator would be 34. Multiply top and bottom of the 9/17 by 2, and you get 18. Multiply the top and bottom of the 1/2 by 17, so you get minus 17. So you get x to the 1/34 power. Okay, what do here? You multiply the exponents. So we have x to the 6, because 3 times 2 is 6. X to the 7th is x to the 14th. And then we'd add them. So we get x to the 20th. Well, let's do the same thing. Let's take 1/2 times 1/3. It's 1/6. And then 2/5 times 1/2. And cancel the 2, so you don't get 2/10. You get 1/5. And then you add the exponents. So we're going to take 1/6 plus 1/5. Common denominator is 30. Multiply top and bottom of the first fraction by 5, top and bottom of the second fraction by 6, and you get x to the 11/30. The rules don't change, no matter how bizarre the problem looks, okay? All right. So what you want to do, again, I would not do this the way Alex does it. I think they make it much harder. They put it in a radical. All I would do is factor and then use the exponent rules. So 16 is 2 to the 4th, raised to the 3/4 power, and that's going to be x. So we take 4 times 3/4, not x, 2. 4 times 3/4 is 3, and the answer is 8. It's much easier than using a radical. Here, we're going to factor the 25 into 5 squared, raised to the -3/2 power. Multiply 2 times -3/2, and you get 5 to the -3rd, which is 1 over 125. Much easier than using a radical. 64 is 2 to the 6th power, to the -1/3 power. So that's 2 to the -2nd, which is 1/4. That's the way I would do it. I would not do it the way Alex does it. Okay, some of this is going to be review of radicals in general, but it's also include fractional exponents. Okay, so here we can't take the square root of the top and bottom, so we're going to multiply by square root of 2 over square root of 2, which is square root of 10 over 2, and that's pretty simple. Now remember, do not rationalize right away. You can cancel the 3 and the 12, and now that's the square root of 1 over the square root of 4. Square root of 1 is 1, square root of 4 is 2. Okay? You can't cancel the 5 and the 12, But what you can do is simplify the square root of 12. So again, don't rationalize unless you need to. And the square root of 12 is 2 square root of 3. Okay, the 2's not a problem. It's the 3 that's the problem. So we just multiply by square root of 3 over square root of 3. And again, none of this should be new to you. That's all over 6. Okay, well, how about this? We're going to multiply top and bottom by the 5th root of 2 to the 4th power. And again, I've shown you this. Again, this is review. So we have the 5th root, and we have 16 times 3 is 48, all over 2. Okay, how about this one? Okay, we're going to multiply top and bottom by the 7th root. It's now 2 to the 1st, so we need 2 to the 6th more. And y to the 3rd, we need a y to the 4th more. So we get the 7th root of 2 to the 6th times, that's 64 times 3. So it's going to be 12, 192, I believe. 192 y to the 4th all over 2y. Okay, again, to remind you here, you're going to multiply by the conjugate, which is 2 minus square root of 3 over 2 minus square root of 3. So we get 2 square root of 5 minus square root of 15 all over 4. And remember, the middle term cancels here, so we get minus 2 square root of 3 plus 2 square root of 3, which is going to cancel. Let me make that a little nicer looking. Sorry, they don't cancel, they subtract. And then minus 3. Now the bottom all becomes 1. It won't normally become something like that, but so we get 2 square root of 5 minus square root of 15, and in this case, it's all over 1. So it just is that. Okay, the 4th root of 16, that's simply 2, because what number times itself 4 times gives you 16, 2. Again, I would not, for number 8, I would not put a radical. I would just call it 2 to the 4th raised to the 1/4 power, which is 2. And by the way, number 7 and 8 are the same problem, just written 2 different ways. Again, for number 9, that's 3 to the 4th raised to the negative 3/4 power, which gives you 3 to the negative 3rd, or 1 over 27. Okay, number 10, again, with negative exponents, I don't really deal with negative exponents except on number 11, where you distribute the exponent first. But here, I have x to the 3/2. The x to the 1/4 goes to the bottom, because it's a negative exponent, and the x to the 1/3 is already on the bottom. So then what are we going to do? We're going to take x to the 3/2 minus 1/4 minus 1/3 power. So we'll get a common denominator, which would be what? 12. And the first fraction becomes 18/12. The second fraction becomes 3/12. And the third fraction becomes 4/12. So that's x to the 11/12 power. Okay, in this case, again, the only time I deal with a negative exponent is when I have to distribute the exponent. And I can do that because there's no plus or minus between the things in the parentheses. So I'm going to take the negative 1/4 and give it to the half. So that would be k to the 1/2 power, because negative 2 times negative 1/4 is 1/2. And then I'm going to give it to the 1/3. So that's k, and we have 1/3 times negative 1/4 is negative 1/12. Now I'll deal with the negative exponents. We have k to the 1/2 all over k to the 1/12. And now we're going to subtract 1/2 minus 1/12. We'll get the common denominator, which is 12. And that'll be 6/12 minus 1/12 is k to the 5/12. Okay, last one. We're going to take 4/5 and subtract 2/3. Common denominator is 15. So We'll get 12/15 minus 10/15, which gives us x to the 2/15 power. Okay? I'm not really telling you much new here, to tell you the truth. The only thing here is like problems like this, like 9, where I'm telling you don't use a radical. Don't do it the way Alex does it. Just treat it as an exponent, but you have to factor the base first, and then just use the exponent rules. That's kind of what I'm telling you all here. Just use the exponent rules. The exponent rules are not changing, right? These exponent rules are the same as the previous exponent rules. Okay? So hopefully that helps. Not, ask me some questions. Have a good day, everybody.